Good morning everyone. Today I am going to present methods of data inputs in R. In this session we will learn how to create different data structures, import and export data, manage missing values and work with date values in R. Vectors. A vector is the simplest data structure in R. It stores elements of the same data type such as numeric, character or logical values. We can create vectors using the C function and access specific elements using index positions. Vectors are widely used for storing and processing one-dimensional data. Matrices. A matrix is a two-dimensional data structure. All elements in a matrix must have the same data type. We create matrices using the matrix function by specifying the number of rows and columns. Individual rows, columns or elements can be accessed using row and column indexes. Then comes arrays. Arrays are similar to matrices but can have more than two dimensions. They are useful for storing multidimensional data sets such as images, simulation results and scientific data, or provides the array function to create arrays. Data frames. A data frame is one of the most commonly used data structure in R. Unlike a matrix, different columns can store different types of data such as numeric, character and logical values. Data frames are ideal for storing tabular data sets similar to Excel spreadsheets. We create them using the data.frame function. Lists. A list is a collection of different types of objects. It can contain vectors, matrices, data frames, strings, or even other lists. Elements in a list are accessed using double square brackets. Lists are useful when we need to group related but different kinds of data together. Then comes factors. Factors are used to represent categorical or nominal data. For example, gender, department or product category can be stored as factors. Internally, R stores factor values as integers while displaying their corresponding labels. Factors help statistical functions correctly interpret categorical variables. Useful functions. R provides several built-in functions for managing objects. Functions like length, class, names, string, cbind and rbind help us inspect and manipulate data. Commands such as ls list all objects while rm removes unwanted objects from memory. Then comes importing data. R supports importing data from many external sources. Data can be imported from text files, Excel, SPSS, SAS, Stata and databases. Different packages are available to simplify the import process depending on the file format. Importing CSV files. CSV files are one of the most common data formats. In R, we use the read read.table function with appropriate parameters to read comma separated files. We can specify column names, separators and row names while importing the data sets. Then importing Excel files. Excel files can be imported in different ways. One recommended approach is converting the Excel file into CSV files file format before importing. Alternatively, we can also use packages such as RODBC can directly access Excel worksheets. Then importing SAS data. R can also import SAS datasets. The foreign package enables users to read SAS transport files. This feature is particularly useful when migrating data from statistical software into R. Keyboard input. Instead of importing data, we can create data sets manually. We first create vectors and combine them into a data frame. R also provides a spreadsheet style editor where users can enter and edit data interactively. Exporting data. After completing analysis, we often export results. R allows exporting data to text files, Excel spreadsheets, SAS, SPSS, and other formats. Different packages support exporting data according to project requirements. Viewing data. Before analysis, it is important to inspect the data set. Functions like ls, names, string, head, and tail allows us to understand the structure and contents of the data. These functions help identify errors and verify that the dataset has been imported correctly. Variable labels provide meaningful descriptions for variables. The HMISC package supports assigning labels to variables. These labels improve documentation and make datasets easier to understand during analysis. Value labels. Value labels assign descriptive names to code values. For example, numeric values such as 1, 2, 3 can represent red, blue, and green. Or uses factor function for a nominal data and ordered function for ordinal data, allowing statistical function to process categorical variables correctly. Missing data. Missing values are represented in R using NA, while invalid calculations produce NaN. Functions like is.na function, na.omit, and complete.cases help identify and remove missing values. When we use calculate statistics while ignoring missing values by using the na.rm equal to true option. Date values. Dates are handled using the date data type in R. The as.date function converts character strings into dates. Functions such as sys.date function return the current date, while format allows dates to be displayed in different formats. Date calculations such as finding the difference between two dates are also supported here. See, these are some formats supported by R programming. Then comes a summary. To summarize today's presentation, we learned about vectors, matrices, arrays, data frames, lists, and factors. We explored importing and exporting data. We discussed viewing data sets, labeling variables, handling missing values, and working with dates. These concepts are essential for preparing data before performing statistical analysis in R. Thank you.